by omission, ignore the fact that you've levelled your tool, but you do leave enough detail for the actual people who know how the world works to point out that his Polaris measurement for latitude is a flat Earth proof also. There's quite a few flat Earth proofs in here, Dave, including latitude. How'd you measure latitude? Oh, it's an elevation angle measurement of a flat plane to Polaris. Yeah, you'll need a flat plane for that.
I am Nathan Oakley, and in this video I'm going to use Dave McKeegan's use of the EQ mount to demonstrate how they have hijacked a flat Earth measurement and turned the protractor that you can see on screen wrapped around this EQ mount on the equatorial plane into a globe. The protractor on screen now in the upcoming diagrams that you'll see throughout the video response to Dave McKeegan gets represented as the globe. So when they describe 1 degree for every 60 nautical miles, they're describing the turning of the protractor that the globe has hijacked to call the surface. In reality, what you're actually looking at on screen is a representation of a protractor wrapped around the telescope, measuring an angle between the flat surface and the star in the sky. For latitude, this would be Polaris. Now, when you level an EQ mount, you are effectively drawing out a protractor around you. And the globe Earth has taken that and turned it into the surface. In reality, we measure Earth flat. Smash the super chat, leave a thanks. If you enjoyed the video, I've been Nathan Oakley. Enjoy.
Now, there are different types of trackers. You can get guided ones, such as this telescope mount, which has motors that control both its rotation and the telescope's elevation. And you set this up by selecting 2 or 3 stars as a reference in the handset, and then you point the scope at each of those reference points, and from that, the handset can work out exactly where you are in the world and where everything else is in the sky.
How does that relate to the surface? Because the machine's got to be levelled, and the axis to measure elevation is the angle with respect to the levelled tool on a level surface. That's how you get the elevation. That's what it's detailing when it references the stars in their position. Yeah, it's their elevation angle. That's a flat Earth measurement that you're referencing. Were you unaware that that elevation was an angle with respect to the level of the tool that you've used? Because it is.
I could then say on this that I want to view the Andromeda Galaxy, and it would drive the telescope round to it and keep it tracked.
How would it know? Would it be because we've tracked the positions with respect to the ground? Yeah, it would. These positions are logged in the almanac. We know where the stars are going to be because for quite a considerable period of time we've been tracking their motion. And their motion is tracked with respect to their angle. So their elevation, as you described it, is an angle description with respect to a horizontal plane of reference. The same horizontal plane of reference that you levelled your tool to. Notice he hasn't mentioned that yet. Not once. 6 minutes into the video. Over halfway.
That's how he's going to get away with it. He's never going to reference the ground.
Yeah, all he's done is reference the sky, but he referenced the sky with the elevation of the star. So I can still use his words to describe how those positional pieces of information for the star are with respect to their elevation, and that's an angle off a plane. 100 people watching my show. Please let Dave know that his reference, if he doesn't actually even address the equatorial plane, that this is described when actually measuring something called the celestial sphere, which is with respect to a equatorial plane, because that's how this tool works. Everything he's detailing is flat, but he's just not mentioning it. He hasn't mentioned levelling the tool.
You know, people could argue that that's possible on a flat Earth, since the telescope knows where everything is.
All right. No. The fact that you're levelling it to the equatorial plane and then measuring the angles, that's elevations, of the stars with respect to that plane that you levelled the tool to. So it's a prerequisite, Dave. That's why I was confused at the beginning. You seem to think that without highlighting the prerequisite levelling of the tool with respect to the equatorial plane, so you can measure these positions to get reference of the stars and where they are in elevation. Yeah, that's a flat Earth prerequisite, Dave. But now you're going to ponder how that might not work on a flat Earth? That's a prerequisite.
This equatorial mount, however, isn't as fancy. With this, you have to face it either directly north or south, depending on which hemisphere you're in.
Sorry, north or south are directions on a flat Earth, my friend. When you say which hemisphere you're in, are you talking about the hemispherical positions of the stars that you reference? Because that's all you've referenced so far. Well, that's a hemispherical celestial sphere that's denoted off a flat plane. So when you say hemisphere, the only hemisphere that's going to be with respect to this tool is the celestial sphere, not globe Earth. That doesn't factor into you levelling your tool to the equatorial plane. No, again, you haven't mentioned it yet. I wonder why.
You then wind this elevation dial to match whatever your latitude is.
Latitude? What's latitude? Oh, would that be the elevation angle measurement to Polaris off a flat plane? Yeah, it would, wouldn't it? So this tool and these markings only work on a flat Earth, Dave, because they're measuring elevation angle measurements to Polaris. That's what latitude is, Dave. Latitude is a flat Earth proof. It's the flat Earth proof that means we don't get eradicated. Obviously, you're going to get all the traffic when people search for your boring crap, interjected with sponsorships, before you even get to, oh, by omission, ignore the fact that you've levelled your tool. But you do leave enough detail for the actual people who know how the world works to point out that his Polaris measurement for latitude is a flat Earth proof also. There's quite a few flat Earth proofs in here, Dave, including latitude. How'd you measure latitude? Oh, it's an elevation angle measurement of a flat plane to Polaris? Yeah, you'll need a flat plane for that, like this tool does.
So if you're at, say, the North Pole, you're at 90 degrees north elevation, you wind this dial.
Sorry, how can you be at 90 degrees on a sphere? There is no 90 degrees to a spherical surface, Dave. Do you not understand how spherical surfaces work?
Until you get to 90 degrees, and the mount is pointing straight up towards Polaris.
Straight up towards Polaris is a flat Earth prerequisite. Up. What, with respect to horizontal? Like vertical? Yeah, you're describing flat Earth prerequisites, my friend. Meanwhile, you have to level this tool, and what you've just plonked it on has no level surface whatsoever.
If you're at around a 45 degrees latitude on Earth...
What, 45 degrees? That would be... Polaris is 45 degrees in the sky with respect to a horizontal plane of reference. Yeah, the measurement of that 45 degrees that you've just described to then point at the globe would be a measurement from inside the globe in hell if you're going to infer the globe's used at all. But the actual measurement is off a flat plane, Dave.
And that puts you somewhere around, say, Bordeaux, for example. You wind 45 degrees onto this mount, and you can see, relative to the globe, the mount...
No, the mount isn't moved round at 45 degrees. The mount's still levelled with the ground. You levelled the tool. You see, what Dave's now showing you, because he's a scumbag, liar, and deceitful, is the tool no longer being level. No, Dave. You level the tool and it remains level, but you're now showing an audience that the tool is now at 45 degrees. No, your tool doesn't go to 45 degrees. But when I described to lumpy gas in a vacuum in the pre-show and at the start of this live show, how they describe you being on the protractor, you can understand how this level tool at 45 degrees in the centre of the sphere would be a level tool on the equatorial plane. But he's describing the tool now being at 45 degrees. Now, your angle measurement to Polaris is 45 degrees off a flat Earth. The tool's not at 45 degrees, Dave. You level the tool, Dave. Does it still look level, Dave? Is this what you think happens to your tool, Dave? No, it always remains level, Dave. It's a very key detail to using an equatorial mount. It's a detail that you didn't tell your audience about, though, isn't it, Dave? I wonder why you left that part out. Was it so that you could show them that the tool is at 45 degrees when you pretend that the protractor of the globe Earth with the equatorial plane, with you in the centre of it, levelling your tool to the equatorial plane, that means the tool is at 45 degrees. No, the tool's level, Dave. Always level. It's got a bubble in it, hasn't it, Dave? So why would you be telling your audience that your tool's at 45 degrees? It isn't. The angle measurement and the references that you use are all angles off a flat plane. But you think you can just stick the tool at 45 degrees and blag that it's on the protractor you're measuring? No, Dave. No.
mount is still pointing straight up towards Polaris.
Straight up to Polaris? No, it's just pointing at 45 degrees, Dave. It was level when you had it at the North Pole, then you stuck it at 45 degrees. So you're talking in double speak, my friend. Contradiction in terms. Dave needs his tool, says Roger Ledwell. Thank you for the super chat.
Likewise, at the equator, it's at 0 degrees, and again means the mount is pointing up towards Polaris.
So you think that when you level your tool is standing sideways, Dave? Because you're literally telling the audience that your tool's lying on its side. No, Dave, at no point does this tool do that. No, Dave. Your tool's always level. You level the tool when you set it up. The tripod hits the ground. It doesn't hit the wall next to you. But that's what he's telling his audience. Because in order to do this, you have to take the tool that's level and the angles to Polaris, that's 45 degrees, and infer that you are on the protractor that is being made with the angle measurements of this tool. Therefore, the tool's at 45 degrees. No, it isn't. Tool's level. Always.
Perfectly on the equator, you also have the option of being able to point south as well, not just north. Obviously, if you're south of the equator, you then have to point this directly south.
No, Dave, you level the tool. That's what you do. You level the tool.
Now, in the northern hemisphere,
Why hasn't he mentioned this? We are literally at 7 minutes and 26 of this 11-minute video. And he hasn't once told the audience that this tool requires leveling. He hasn't said it once.